Assalamualaikum. Good afternoon, everyone. So for today's lecture, we are going to cover benzene and its derivatives. So in chapter benzene, it's very simple structure because it's not many reaction there. And the mechanism also, we have only one mechanism. Okay. So I will explain to you within this 1 hour is the introduction part, how we name the benzene and its derivative and the chemical properties involved. Okay, so we need students must be able to describe the aromaticity of the benzene and then calculate structure for benzene and resonance structure of the benzene. Number two is to draw and name the benzene derivative according to the IUPAC nomenclature. Number three is to give the example of benzene as substituent. Okay. First of all, aromatic compound is referring to the benzene ring in its molecule. So anything that is has benzene ring, we call it as aromatic compound. Actually, aromatic compound is more than benzene. Ada benda lain lagi selain daripada benzene, tapi untuk syllabus matrikulasi kita hanya refer kepada benzene ring sahaja. Then benzene ring, it is also known as arene and the formula is C6H6. Okay, we can draw benzene ring as the first structure or the second structure. Okay, the first structure is the expanded where we seldom draw like this and usually we draw the second structure. Okay, where we hide the carbon and the hydrogen. And if we draw the cubical structure, we call it, this structure is a cubical structure for benzene because the double bond and single bond is alternate. Okay, so they will generate the resonance structure if the double bond alternate to the single bond. If we see the formula of the benzene ring, okay, if we see the molecular formula, something that has carbon and hydrogen ratio is almost 1:1. So it is expected that the compound consists of benzene ring. Okay, and then the benzene is actually a resonance hybrid of the two cubical structure. This is the first cubical structure and this is the second. Since the carbon, the pi electron at the pi bond are delocalized, meaning that the electron is keep on moving. So the double bond will go to the single bond and it will make double bond here, right? So same goes to the next double bond, will go to the next single bond, the double bond will go to the single bond. So the location of double and single bond are alternate. Finally, because the electron keep on delocalized or keep on moving, we call it as delocalized electron. So we can draw like the third structure. So the third structure also benzene ring. It is a resonance hybrid structure. And the 6 pi electron completely delocalized around the ring, as I mentioned earlier, or we can say they are completely conjugated because it is same whether you draw the structure 1 or number 2, structure 2. Okay, how to name this benzene for mono-substituted benzene. Mono mean one, only one substituent attached to benzene ring. Benzene is the parent and the substituent indicated by a prefix. So if it is halogen, it will be chlorobenzene, bromobenzene, okay? NO2, when attached to the benzene, we call it nitrobenzene. Okay, and then ethyl at the benzene ring, ethyl benzene, and then methyl benzene, and then OH directly bonded to benzene ring. As we learn in tutorial alcohol, it can be hydroxybenzene ataupun phenol. Next, we can also have the COOH bonded to benzene. We call it as benzoic acid or benzene carboxylic acid. So this we will learn further details in chapter carboxylic acid. Next is NH2 attached to the benzene ring. We call it as aniline. Okay, the common name is aniline. Also as a IUPAC name, aniline. or aminobenzene. The parent is benzene, and then NH2 will be the substituent. We call it as aminobenzene. Next is the C double bond O is ketone. So ethane, 2 carbon. So it is ethanol. Ethanol attached to the benzene ring. So it can be phenyl ethanol. Okay, in this case, the C double bond O is the parent. The 2 carbon, this 2 carbon is ethanol. Okay, so it will be the parent and the benzene ring become the substituent. So it will be phenyl ethanol. Or the common name is acetophenol. Ace mean 2. Okay, 2 carbon connected with phenol, so acetophenol. The other one is benzaldehyde because benzene connected to the aldehyde methanol. So it is benzaldehyde. Okay. Relative position substituent indicated by the prefix ortho, meta, and para. Okay, or by using the number to state the locale of the substituent in benzene. So this only apply when we have 2 substituent attached to the benzene ring. Okay, if the substituent located at carbon number 1 and carbon number 2, therefore it will be meta. Bukan. Ortho. So, parent is benzene. So, we have substituent dibromo. Where is the location of the bromo? At carbon number 1 and number 2. So, it will be 1,2-dibromo benzene. Or else, 1,2 is substituted by the another prefix called ortho. Ortho mean when the substituent located at carbon number 1 and carbon number 2. Okay, so it will be 1,2 ortho, 1,2 dibromobenzene. So kalau kita tak nak mention 1,2, kita boleh cakap ortho dibromobenzene. Ortho, kalau you cakap ortho 1,2 1 dibromobenzene, apa lagi? If we say ortho dibromobenzene, so it is understood that the ortho is the bromo is located at carbon number 1 and number 2. Okay, ortho 1 and 2 substituent dia. Yang kedua adalah pada kedudukan 1 and 4. So it will be 1,4 1,3 dibromobenzene. Or if 1,3, we can substitute by meta. Meta is when the substituent located at 1 and 3. If this pair of substituent located at 1 and 3, it will be meta-dibromobenzene. And we have 1,4 location. Okay. So it can be 1,4-dibromobenzene or 1,4 we substitute by para-dibromobenzene. If we say para-dibromobenzene, it is understood that the bromine is located at carbon number 1 and number 4. Next is 1,2-dinitrobenzene, 1,2-dinitro bla 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 ni. So kita boleh numbering dia sebagai kat sini ortho-dinitrobenzene, ortho-dinitrobenzene, para, meta dan 1,4 para dimethylbenzene. If 2 different substituent attached, can we use ortho, meta, para? Okay. Kalau ada 2 substituent, kita mesti pilih yang mana yang menjadi parent yang baharu. Priority order of common substituent. Kita kena tengok priority dia. So the highest priority is carboxylic acid, COH, SO3OH, carbonyl compound, cyanol compound, C double bond O, ketone, ini aldehyde, alkohol, amine dekat bawah dia, OR is ether, triple bond, double bond, R, NO2, halogen. So halogen dekat tengah. So alkohol, kalau sekarang you tengah melalui tutorial alkohol, bila kita nak naming, siapa yang akan diberi priority untuk menjadi parent? It is alcohol compared to haloalkane. So nanti kita jumpa dalam chapter carboxylic acid. Carboxylic acid diberi highest priority compared to alcohol and the other organic compounds. Okay, so priority is given here. Okay, let's say we have benzene and the carboxylic acid and the nitro. So who will be the benzene? Who will be the parent? So we choose. Therefore, this carbon is carbon number 2. So the parent will be benzoic acid as the benzene ring attached to the carboxylic acid. So parent benzoic acid and NO2 will be the substituent. It will be 2-nitro benzoic acid. Okay. If we want to substitute with the auto-metapara naming, we can substitute by ortho-nitrobenzoic acid. Therefore, we understood that carbon number 1 is the COOH, while ortho means the NO2 nitro located at the carbon number 2. So same goes to this one. Okay, it will be meta nitrobenzoic acid or 3-nitrobenzoic acid and para-nitrobenzoic acid. Next. So here we have OH and NO2. Siapa yang akan menjadi parent? Okay, so according to the list of the priorities, OH is the highest priority compared to NO2. OH is directly bonded to the benzene ring. We call it as phenol. So the parent will be phenol and the NO2 will be the substituent located at carbon number 3. So 3-nitrophenol ataupun meta-nitrophenol. Next, we have COOH and OH. The highest priority will be given to the COOH. So the parent will be benzoic acid. And OH will be the substituent located at carbon number 4. Therefore, it will be 4-hydroxybenzoic acid or para-hydroxybenzoic acid because the location is between 1 and 4. And the next one is we have chlorine and bromine. Both of them are halogen. So priority is not given to anybody because they are same priorities. So the parent will be benzene. Therefore, the chlorine and bromine must be substituent as a prefix. But when we arrange alphabetically, bromo comes first. So it will be 1-bromo 4-chlorobenzene. Okay. Boleh tak kita buat 4-bromo 1-chlorobenzene? So we choose the first one as it is the according to the IUPAC nomenclature, we are following the alphabetical order. Alright. Next, we have carboxylic acid, but the benzene ring attached to 2 carboxyl group. Therefore, we can name it as 1,4-benzene dicarboxylic acid or tak apalah, pilih je lah 1,4-benzene dicarboxylic acid. Okay, so this one is very rare. Okay, kalau ada 3 substituent ataupun lebih 4 substituent, so kita ikut position substituent must be indicated by 4 by the numbers. Tak boleh lagi pakai ortho meta para, mesti bagi nombor saja, and the substituent are listed alphabetically when writing the name. And then the carbon atom bearing the substituent that define the new parent name is carbon number 1. Okay, for example, this benzene ring. So kat mana kita nak locate carbon number 1? Okay, dekat yang paling banyak substituent ni kita pilih carbon number 1 dan kita pusing ke bawah supaya dia menghasilkan loken yang paling sedikit. So it will be 1 to 4 tribromobenzene. Next, we have chlorine, bromine and iodine. So the parent will be benzene and the substituent are the same, halogen. Okay, so we try to start from iodine or chlorine. Okay, now here we start from chlorine because chlorine carbon number 1, 2-bromo and one is iodine. Okay, sebab klorin datang dulu kan, so start with klorin lah. Alright. Okay, selepas naming, kita terus masuk kepada dia punya reaction. Naming. Oh ya. Yeah. Okay, naming, bila ada benzene, bila carbon benzene attached to the carbon chain, so the carbon chain is given priorities to be apparent. Okay, for example here we have butane and then double bond, so it will be butene. So butene at carbon number 1, number 2, number 3 is benzene ring. Benzene ring when becomes substituent is phenyl. So it will be 3-phenyl butene ataupun 3-phenyl 1-butene ataupun 3-phenyl but1-ene. Okay, yang paling common yang you belajar dalam alkene adalah 3-phenyl 1-butene. Sama juga kalau kita ada alkohol and then straight chain dia alkohol, ada OH and then ada benzene ring. So parent dia kita mesti pilih yang ada alkohol sebab priorities tadilah, hierarchy priorities. Kita nak bagi jadi parent dia benzene atau parent dia alkohol. So alkohol lebih higher priority, therefore you choose alkohol. Therefore benzene ring become substituent. Tapi kalau benzene ring ada carbon, ini kita panggil benzil. So bromobenzil ataupun bromomethylbenzil. Okay, ini metanol and then benzene jadi substituent, dia jadi phenyl methanol ataupun benzil alcohol. Benzil is referring to the benzene ring that attached to carbon. Okay. Next is the chemical properties of benzene. In benzene, okay, kita dah masuk part 3. Part 3 ke? Okay. This part is referring to the how the benzene react. Okay, how the chemical properties benzene. Number 1 is benzene is undergo electrophilic aromatic substitution. Aromatic is referring specifically to the benzene and substitution is referring to the benzene. Benzene will never undergo addition, okay, because benzene is very difficult to open the double bond. Therefore, it will undergo substitution. Each of the carbon in the benzene ring has one hydrogen. So one of the hydrogen will be replaced by the electrophile. So the electrophile will substitute the hydrogen, therefore electrophilic substitution. And benzene is the source of electron or the site of nucleophile because high density of electron. There will be pi electron there. So benzene adalah kaya elektron, nucleophile. Sebab tu electrophile yang datang substitute. Okay, bila kita nak tengok dia punya mechanism, ada 4 reaction saja dalam benzene, 4 reaction. So keempat-empat reaction ni mengalami mechanism yang sama. Okay, 4 jenis tindak balas, 4 jenis lah. 4 tindak balas tapi ada dengan satu mechanism yang sama. Mechanism tu ada 3 step. Formation of electrophile. Number 2 is formation of adenium ion. Number 3 is deprotonation. Kita tengok yang tindak balas yang pertama adalah halogenation. Okay, where benzene react with bromine. Kalau bromine saja tak jadi apa-apa. Tetapi bila bromine react dengan benzene in the presence of the catalyst, so barulah bromine ni boleh menjadi nucleophile, electrophile, and barulah bromine ni boleh substitute hydrogen there. Okay, and the double bond in the benzene ring is remain the same. Only hydrogen be substituted by the Br. So dapatlah bromobenzene. So first one is the halogenation. Okay, in order for the reaction to occur, there must be in the presence of catalyst, which is the Lewis acid. Okay, apa observation yang membuktikan ada tindak balas ini? We can see that the bromine colour turn to decolorize. Reddish brown of bromine decolorize. Okay, macam mana nak buat mechanism dia? Number one, the Lewis acid come and polarize the bromine, Br. Br is non-polar. So when this Br2 is close to the Br3, the acid, okay, Lewis acid ni, so dia akan polarize. Okay, so bila dia polarize, dia akan menjadi Br minus dan join FeBr3. So dia jadilah FeBr4. The Br left here as Br plus. So this Br break a bond. Step number 2, the nucleophilic, the benzene ring will attack the electrophile. Okay, benzene ring sangat kaya elektron, so Br miskin. So dia akan attack. Attack maksudnya buka double bond, gunakan 2 elektron untuk form bond between carbon to the Br. So the bond form, kita lukis macam ni. Okay? Alright. Kalau yang ni you tak lukis pun tak apa. H yang sebab samun ni tak lukis pun tak ada masalah. Yang penting you lukis antara 2 karbon yang terbuka ni. Okay. Setiap karbon mempunyai hidrogen. So kat sini ada 1 hidrogen, sini pun 1 hidrogen, and then Br masuk dekat sini. Macam mana Br boleh masuk? Dia guna bond pi ni. So the double bond is no longer there, and then it is positively charged here because dia nak 4 bond tapi tak cukup elektron. So dia positif. Okay. So copy balik 4 ketul ni kepada 4 ketul pula. Copy balik benda ni seluruh arinium ion. This is arinium ion. Okay. Copy kepada 3 benda. 3 bahagian. Okay. Copy macam ni. Copy je without any double bond there. So, bila dia dah copy siap-siap tadi kan, tengok dekat sini. Sekarang, dekat sini, karbon ni tidak cukup elektron. Therefore, double bond ni akan memberi elektron dia ke sebelah. Bila dia bagi, positif ni, dia dah form double bond there. Okay, so positif ni dah tak ada kat sini lah. Double bond dekat sini. So, ada orang yang lebih miskin pula dekat sini. Yang tak cukup 4 bond. Sebab double bond dia dah beralih ke sebelah. So, dapat positif. Bila dia positif pula, pi elektron di sini akan memberi elektron kepada dia. Bagi elektron, tunjukkan anak panah daripada double bond ke positif. So, dia jadi struktur yang ketiga, arinium ion. So, dapat positif. Bila positif, orang sebelah ni, yang ni, bagi balik dekat dia. Positif kat sini balik. Ulang benda yang sama yang ni. Bila sampai sini, pergi sini lagi. Okay, so these 3 structure we call it as resonance structure of arinium ion. Okay, macam mana nak tunjuk resonance structure? Ini, satu, kita ada full, apa ni? Backward arrow ni. Okay. So, pilih salah satu structure daripada arinium ion untuk kita form balik double bond. And then, at the first step, we have FeBr4 minus form, and then it come and take the hydrogen. Okay, ingat our aim is to substitute the Br, the hydrogen, substitute the hydrogen with the Br. Once Br masuk, hydrogen kenalah keluar sebab untuk membentuk double bond. So hydrogen keluar, siapa yang ambil hydrogen ni? FeBr4 come and take the hydrogen and form bond between H and the Br. Okay, so the bond between carbon and hydrogen there, the 2 electron is given to the carbon positive to make the new double bond. So, dia jadi double bond and then H ni pergi mana? H bergabung dengan Br, FeBr3. Br tu berpisah dah keluar daripada FeBr4 minus tu, dia jadi FeBr3. So FeBr3 remain the same because it is catalyst. H keluar, Br pun gabung dengan Br. Okay, so itu adalah 3 step mechanism bagi halogenation. So step yang sama digunakan untuk nitration, Friedel-Crafts alkylation dan Friedel-Crafts acylation. So untuk kuliah hari ini saya hanya tunjukkan satu sahaja mekanisme, di mana satu mekanisme ini apply untuk 4 reaction. Okay, 4 reaction electrophilic substitution. Okay, the first one, second reaction is nitration. Tadi halogenation, ini nitration. Benzene, one of the hydrogen at the benzene ring is substituted by the NO2+. So dapat nitrobenzene. Ini berlaku apabila benzene ring react dengan nitric acid, concentrated nitric acid in the presence of concentrated sulfuric acid at the temperature 50 to 55 degrees Celsius. Then dapatlah nitrobenzene. Okay. And then bila dapat ni, tindak balas ni, macam mana kita tahu dia dapat nitrobenzene? Kita dapat yellow oil. Warna kuning yang nampak macam berminyak. That one is nitrobenzene. Okay. So dia masih lagi electrophilic substitution. Step 1 sama. Okay. Step 1 dia kita boleh buat macam ni je lah. Nitric acid, H2SO4, pecahkan nitric acid. So dia hasilkan electrophile, orang miskin ni, NO2+. Step yang kedua adalah benzene ring attack electrophile. Okay. Lepas tu tunjukkan adenine ion benzene ni, bla 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 bla. Lepas tu tunjukkan hidrogen keluar, HSO4- yang datang ambil. Lepas tu form balik double bond. So H dah keluar, tinggallah NO2. Okay. So itu adalah apa ni? Reaction. Okay, and the last part is the chemical properties. Kita nak tengok Friedel-Crafts alkylation dan acylation. Okay, we move to the next. Okay, kita perlu kita recap balik yang benzene ni dia tak sama dengan alkene, di mana alkene dia boleh undergo addition, okay, with Br2 in inert solvent. Okay, macam mana kita tahu ada reaction? Br2 akan berkurang. Tapi bila kita react Br2 dengan benzene, there's no decoloration. Maksudnya warna bromin tu kekal. Maksudnya benzene ring tak react dengan Br2. Benzene ring juga tak boleh oxidize. Benzene ring tak boleh undergo hydrogenation. Kita tak boleh buka double bond untuk undergo oxidation, hydrogenation ataupun bromination. So stability of pi electron system will be lost if benzene undergo addition reaction. So sebab itulah benzene ni tidak akan undergo addition reaction. But it will undergo substitution only. Okay. Sekarang kita pergi ke reaction. Tadi kita dah halogenation and then nitration. Sekarang kita pergi ke tindak balas yang seterusnya. Halogenation dah. And then nitration pun dah. Okay, mekanisme yang sama juga, 3 step. Okay, ini adalah tindak balas yang ketiga iaitu Friedel-Crafts alkylation. Nama dia alkylation. Bila alkylation maksudnya kena tambah alkyl group. Okay, so tindak balas dia adalah benzene ring react dengan haloalkane in the presence of Lewis acid, AlCl3. So Cl kita putus dan kita sambung pada benzene. Okay. Tempat benzene yang asal-asalnya ni ada hidrogen and then the hydrogen is substituted by the alkyl group. Sebab tu nama dia Friedel-Crafts alkylation. Friedel-Crafts ni adalah nama dua orang saintis lah. Okay, and then kita hanya belajar substitute dekat satu tempat saja. Okay, yang ni you abaikan. Okay, kita tak belajar major minor lah. Okay, yang keempat adalah Friedel-Crafts isolation where benzene react with acyl chloride. Acyl chloride tadi alkyl chloride kan? Acyl chloride adalah the Cl bonded to the C double bond O. So, kita potong dekat Cl juga, sama juga bentuk dia. Sambung balik dekat C double bond O CH3. So, akan dapat ketone. Okay, so ini Friedel-Crafts isolation. Pun perlukan Lewis acid sebagai catalyst. Okey, mekanisme dia sama, boleh rujuk nota. Okay. Sama juga, 3 step juga. Dia tak sama dekat step 1 saja pembentukan electrophile. Step 2, step 3 sama. Okey, next. Tadi 4 reaction tu adalah electrophilic aromatic substitution di mana 4 tindak balas tu berlaku straight away at the benzene ring. Maksudnya tindak balas tu berlaku dekat benzene ring. Tetapi sekarang kita nak tengok tindak balas yang berlaku dekat side chain dia. Contohnya ada 2 tindak balas yang kamu akan belajar, tindak balas dekat side chain dalam benzene ring ni, iaitu pertama dekat oxidation alkyl benzene. Yang kedua adalah free radical substitution. Okay, macam dekat alkane. Contohnya, methyl benzene ni, okay, this benzylic carbon can undergo, alkyl benzene can undergo oxidation with KMNO4 ataupun any strong oxidizing agent such as sodium dichromate. The condition is hot and then in the presence of acid. Okey, syarat untuk tindak balas dia boleh oxidize atau tidak, dia mesti mempunyai benzylic hydrogen. What is benzylic hydrogen? Benzylic hydrogen adalah hydrogen yang attach pada benzylic carbon. What is benzylic carbon? Carbon that is bonded to the benzene ring. So, kalau benzylic carbon ni ada hydrogen, so dia boleh oxidize. Okay, this part dia boleh oxidize tak? Boleh. Carbon ini ada hydrogen. Sekurang-kurangnya 1 pun boleh oxidize. So apa produk dia bila dia oxidize? Okay. CH3 ataupun methyl benzene attached to benzene ring, nama lain dia adalah toluene. Bila dia oxidize in the presence of KMNO4 oxidizing agent, berasid, panas, dia akan oxidize jadi carboxylic acid. Okey, katakan kita ada substituen yang lain, nitrobenzene, nitrotoluene. So, kita fokus kepada oxidation dekat alkyl benzene. Okey, NO2 dia tak boleh oxidize dah. So, kita fokus dekat alkyl benzene saja. So, dia oxidize this area and this to be carboxylic acid, COOH. Okay, sebab dia syarat dia carbon yang attach pada benzene ring mesti ada hydrogen. Okay, let's say this one, we have alkyl group, 2 alkyl group at the left side and the right side. Left side boleh oxidize tak? Boleh. Sebab dia ada hydrogen kan. So dia oxidize jadi COOH and the second side alkyl pun ada hydrogen, pun oxidize to the COOH. Walau berapa panjang alkyl attached to this carbon pada alkyl group ni, dia akan tetap dapat COOH. Senang kan? Produk dia itu je. Boleh oxidize? Oxidize jadi apa? Oxidize jadi COOH. Okay? Okay, yang the remaining carbon yang banyak-banyak panjang ni jadi apa? Jadi CO2H2O. Okay, kita boleh kenal pasti kehadiran alkyl benzene. Kita gunakan hot KMNO4 ataupun hot potassium dichromate. Ini you tahu kan, KMNO4 warna purple, potassium dichromate warna orange. So kalau positif, purple colourless. Kalau potassium dichromate, orange jadi green. Okey, contohnya kalau katakan kita tidak ada ni ada. So di CH3 boleh oxidize. CH ni isopropyl ni carbon ada satu hidrogen. Boleh juga oxidize. So compound without benzylic hydrogen are inert to oxidation. Maksudnya alkyl benzene, alkyl group that attached to benzene, kalau dia tak ada hydrogen ataupun kita katakan there's no benzylic hydrogen, so it won't undergo oxidation. Contohnya, okey, contohnya struktur ini. Methyl benzene, okey, kat sini belah kiri ni CH3 yang merah ni ada hidrogen. So dia boleh oxidize. Okey. So since dia boleh oxidize, dia jadi COOH. The other one is the isopropyl benzene. There's no benzylic hydrogen. Okay, look at this carbon. Carbon that bonded to the benzene ring. Okay, mana dah? Carbon that bonded to the benzene ring. So this benzylic carbon has no benzylic hydrogen. So this area cannot be oxidized. So they remain as isopropyl benzene tu. Okay, second is the halogenation at the side chain. Tadi halogenation dekat benzene ring. Sekarang kita ada halogenation di side chain. So dia akan undergo macam kita belajar dekat alkane jugalah, iaitu free radical substitution. Di mana dia melibatkan pembentukan free radical. So simple je. Kalau kita kata free radical substitution, it must be in the presence of UV light. So the chlorine, UV will break the chlorine homolytically and it will form chlorine free radical, and then chlorine free radical substitute one of the hydrogen at the alkyl, not the benzene. Nothing's happened at the benzene ring, so it will remain the same benzene. One hydrogen is substituted by the Cl radical. So it will form chloromethyl benzene. Itu saja yang kita belajar dalam benzene. Okay, so benzene ada 4 reaction. Ini contoh yang samalah, free radical substitution. We can summarize, there are 4 reactions that occur straight away to the benzene ring. The first one is the halogenation. Number 2 is nitration. Number 3 is free radicals. First one is halogenation, where halogen is attached to the benzene ring. Nitration is NO2 attached to the benzene ring. Free Friedel-Crafts alkylation, where the alkyl group is attached to the benzene ring, and the fourth one is the Friedel-Crafts acylation to form the ketone. Okey, ini adalah tindak balas yang berlaku pada benzene ring. Ada 2 lagi tindak balas yang berlaku pada side chain. Contohnya dekat kita dapat alkyl benzene. Alkyl benzene ni dekat sini R ni boleh undergo 2 lagi tindak balas, iaitu oxidation dan juga free radical substitution. Okay, so total ada 6 tindak balas. 4 dekat sini, 2 dekat sini. Okay, boleh oxidize ni syarat dia dengan mempunyai carbon, benzylic carbon, ada benzylic hydrogen. Okay, so with that we finish chapter benzene. Itu saja. Thank you.